Prabhav. Prabhav, are you able to listen me?
Yes, sir.
And at your screen, what are you able to see?
Yes, sir.
What?
It's a blank screen. Means page.
Okay, one page. Right, right. So now what is there?
Welcome, sir.
Good. Okay, so this seems fine, but the problem is you have to move it. So please come one or two student and move that side or here. From the first row, please come. Here, here. Just. Otherwise, one other faculty will come and they will call you again to move here. Make sure this chair will not move toward this, and otherwise I will fall down. Please indicate me. It is very awkward, ना? मेरा मुंह यहाँ है, आप लोग यहाँ देख रहे हैं. Okay, then now what I have to do, I will take it words and start. So you have wasted my 10 minutes approximately. आप पहले ही बोल दिए होते कि सर ब्लैक बोर्ड पे पढ़ाइए, तो ये सब तो दिखता रहेगा फिर उनको. तो ये पढ़ाएंगे तो ये फिर रिफ्लेक्ट कैसे होगा कैमरा पे? Come and do. Who knows these things? Come and do. Call him. Call him. Call him. Neeraj Kumar belongs to your class. I can understand those who are saying yes, they are friend of Neeraj Kumar, and those who are saying no, they are not friend of him. Right? Achha, only what I need to do, stop the projector. That's only. ये नहीं है, तो ये तो कैमरे का है। ओके ओके ओके, got it. This time I should move on that side. That side. I mean. Okay. So in the DCS class, I think you don't have to give your attendance. That's the way you were in this from this semester. And what you are doing that after 1 or 2 days, surprisingly, you appear in the quiz, right? So this pattern will go on. I will do this same. However, will make arrangement for you. How will you join the quiz? So most probably, will take some hard copies of question paper and we will distribute to you. On the same time, exact time, they will join at their home. Correct? And you must have been told that the 8 out of 12, 8 best out of 12, the quizzes will be taken out. So till now you have completed seven quizzes, and I saw your records. The grading system, it was very poor, so no problem. Same will continue. Poor performance will continue. Okay. So today onwards we will be seeing the units. That unit was fourth unit, I think. Combinational circuit, combinational logic design. So the first part you have completed, where I believe that you have studied this adder circuit, subtractor circuit, and multiplier. Okay. If not, so I think only one of these three will be remaining. So you will go, and this is the homework for you. You will study by yourself. So I will start from the second part of the fourth unit. That is, there are 4 topics in that. First is encoder and decoders. Second is multiplexer and similarly demultiplexer. And we will be designing the Boolean function with this. These all comes under the MSI, that is medium scale integrated circuit. Okay. And you have seen the Boolean function f of 3 variable. Let me write a, b, c are the variables of this function. And what is this? This is the mean terms. So how do you represent this mean term? You better know from the first unit. Correct. So with the help of this combinational logic circuits, or we can say these are ICs, actually these are available directly. So with the help of these ICs, we will implement this Boolean function. Till now what you have done, you have minimizes the Boolean functions with the help of KMAP or MC method, right? Now we'll implement this Boolean functions with the help of encoder and decoder. एक बार देख लीजिए कि ये सब सही चल रहा है कि नहीं, रिकॉर्ड हो रहा है कि नहीं. प्रोजेक्टर यूज नहीं कर रहा है, इसको बंद कर दीजिए और मुझे ही बताइए कहाँ से बंद करते हैं. अच्छा ये रखा है, ठीक है. और रिकॉर्डिंग ऑन है?
हाँ रिकॉर्डिंग ऑन रिकॉर्डिंग ऑन है।
नहीं, ये तो मैं किया था एक रिकॉर्डिंग ऑन।
हाँ तो वो रिकॉर्डिंग चल रही है सर, आपकी इसकी भी चल रही है।
अच्छा अच्छा ठीक है।
अभी सर आपकी क्लास चल रही है।
ओके, उनको सीधा सीधा रिफ्लेक्ट कर रहा होगा, ये उल्टा तो नहीं जा रहा
यहाँ
होगा?
उल्टा दिख रहा है लेकिन वहाँ पे सीधा दिख रहा है सर। और फिर यहाँ से आप
ठीक है, बट आई डोंट वांट इट। अभी तो नहीं किया कुछ?
अभी सर अभी कुछ नहीं, अभी वो आपको आ रहा है।
और फिर कैमरा भी मूव कर जाएगा इसको करने से?
हाँ सर
करके बताइए।
ये कौन जैसा अभी आ रहा है।
अच्छा 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 अच्छा, 2 प्रेस करेंगे तो मिडिल
2 पे वो चलेगा सर। 2 प्रेस करके तो
1 2 एंड 3 है यार, 1 और 2 है ओनली।
1 और 2 तो सर 1 तो इधर के लिए है, 2 इधर के लिए है।
ठीक,
और
Zoom।
0 प्रेस करोगे तो सर कंप्लीट पूरा बोर्ड जाएगा। अब 0 पे कम बच्चों को कम दिखेगा तो इसलिए सर 1 और 2 पे अच्छा दिखेगा।
So move on that speed।
अभी आप 2 पे हो जब 1 को इधर प्रेस करोगे तो अच्छा लगेगा। अभी 2 पे हो।
हाँ, ये जूम करने के लिए है ना?
हाँ ये जूम करने के लिए वो बच्चे सर वो जूम बच्चे भी करके वहाँ कर लेंगे हो जाएगा।
अच्छा।
मोबाइल देखो उनको जाएगा सर जूम।
करेक्ट, ठीक है, थैंक यू। All right, so in this series first we will see the encoders. What is encoder and what is the decoder? Encoder, as the name suggests, it is used for coding something. Okay, in the design of this digital electronics, you may have encountered that you have so many inputs, but at a time only one input is on, and you want to reflect that at the output. So instead of extending all this line at the outputs, these are inputs, what I want here, that I want to minimize I want to minimize something. I want to design a circuit here that minimize this combination. Means, see, if at a time, let's suppose this is input I0, I1, I2 and I3. Okay, and if I say that if I2 is high and all other are low. Okay, so one way is that at the output you will have to extend these lines, and at the output you will be able to know this one or this one. Let's suppose I2 was high, so I2 will be high. But can we design some logic that can automatically reduce the number of inputs and says that this input was high? Correct. So you know that if there are a combination of n variable, actually this reduces. You should remember this. Encoder reduces the complexity, because when we see the decoder, there is just opposite of encoder that increases the bit or decodes something. So you will be able to find out which type of circuitry is using, where we are using this type of circuitry to minimize the circuit, minimize the logics, and which type of circuitry we should use to expand the logics. Correct. So here, if let's suppose I have n number of inputs, these are my inputs, so I can represent these inputs with the help of two outputs. See here, how can I represent? This is my output y0 and y1. So let's suppose this I2 was high, and I'll say that if I2 is high, then This is my input. This is my output actually. And when you have at the output, that is 0 and 1. Y1 is 0 and Y0 is 1. So you will understand looking at this outputs that this I2 was high. Correct? If you receive at the output that is Y0 is equal to 0 and Y1 is equal to also 0, so you will say that this I1 was high. Something you received, information received at the input I0. Similarly for these cases also. So here what we did, we reduced the complexity. We will design something. In this IC you have gates that are AND gate and OR gate and NOT gate. These three gates are available inside this circuitry, and with this combination of this and inputs, you will able to find out the outputs, and with the help of the outputs you will see which one was high. Correct? So this is the encoder. Multiplexer, will see in this unit you have this multiplexer also. So there are actually in multiplexer there are multiple inputs, but only one output is there. But here on the demand or on the requirement, you can have multiple number of outputs. Let's suppose I want to encode, we'll see this BCD to gray code. Correct? So on the BCD you have how many inputs? 4 inputs. For BCD, this is BCD, this is defined from 0 to 9. So you will have 4 binary bits. So similarly, to convert, when you convert the BCD to gray codes, in the gray code also you will require 4 bits. You know how to convert BCD to gray? No, yes. Okay, we will see it later. But for the time being, you should know that from converting BCD to gray code, at the output also you will require 4 bits. So this way you will have a multiple number of outputs according to the requirements. And what is the decoder? Decoder is just the opposite of this encoder. At the decoder you will have, let me extend this. This is your decoder circuit. So here you have this input I1 and I0. This is, let's suppose this is LSB bit and this is MSB. So according to your input bit, this one of this output will be high. Okay. So if this LSV and MSV, I0 and I1 is 0, 0, so output Y0 will be high, and rest of all will be 0. If it is 0, 1, then this will be high and this will be 0. Okay. So now where can you use this decoder circuit? This is encoder. Let me specify. And this is decoder. And to be specific, this is 2 to 4 decoder. And this is 4 cross 2 encoder. Correct? So where do you use this decoder? In memory interfacing. Sometime what happened, memory is connected in blocks. You know something, means let's suppose I have this, there are lots of bits, they are to be saved in somewhere. So all these bits will be specified in this memory, and I only want to check with this bit. So how do you go? So you will connect, let's suppose there was only 4 block. For the simplicity, we'll see this is the 4 block memory segment. Okay, so here this First block is connected to y0, second is connected to y1, third is connected to y2, and last is connected to y3. And I'm interested to check what is inside this memory block. Correct. So how will you proceed? We'll proceed with sending y2. For y2, what is there? 1 0. Correct. So only this block will be enabled, this will be high, and rest of all these outputs will be 0, thereby all this memory will be not checked. So this way this decoder comes into the picture of this electronics. There are so many applications, so you will be finding all these other applications and let me know what are the applications where we can use the decoder. Yes.
I think it is I0I1 is written.
No, whatever the question is, I have mentioned the LSB and MSB. So there is no problem. In question paper also, they want to make you confused always. In the gate examination or other, if you will appear in the IAS or gate, they will not mention this. They will just mention LSB and MSB somewhere. And they will write like this. This is your decoder, Y2 and Y1. And this is MSB and LSB. So now then where you will be asking the questions? Sir, it should be Y0 and Y1. It should not be. There are two inputs and one is LSB and one is MSB. That's it.
I'm asking that if I1 is MSB, then its weight must be 2.
Okay, did I make mistake here? Yes, so this should be changed. Now is it correct? Okay. So yes, so these we have seen the encoder and decoder. Now we'll see the design of combinational. Actually, we'll implement the Boolean function with this decoder first. Okay, if you were smart enough, so you can ask one question here. Sir, you told me if one of any input is high, then something will be reflect on the output. But what will happen when multiple inputs are high? Okay, so this may be the case. If your I2 and I3 both are high, then what will be reflecting on the output? So here the priority will come into the picture. You will decide the priority. You are the designer. You are the designer of this circuit. So you will decide the priority, which input should take the highest priority and which input lines should take the lowest priority. Based on that, you will be able to find out the output values. So there is a name which is a priority encoder also. We will see that what is the priority encoder. So you have seen that what is the decoder and encoder. So now we'll see what is the priority encoder. And for this, I will have to make some rules. Let I0 have the lowest priority. It means that I1, I2, and I3. So I3 will be at the highest priority. I3 will have the highest priority. Correct. So now we'll make a truth table for this outputs, and you better know how to make the truth table. If you have 4 inputs, I3, I2, I1, and I0, and you have 2 outputs, Y1 and Y0, correct. So see, when all these of inputs are 0 here, if I3, I2, I1, and I0 are 0, so at the output, what will you have? 0 and 0. There is no problem, correct. And let's suppose when there is 1 at the input I0, so what will be the output? 0 and 1. But there is a problem. Let's suppose this is also high. Two inputs are high, and you choose that I3 is I3 is the highest priority. It means that I2 having the greater priority than I0. Correct? So now how will you proceed? Okay. So yes, let me correct it for the simplicity. Let's suppose I3 has the lowest priority and I0 will be the highest priority. So there is no problem now. Now whatever the condition of this, because I0 has the highest priority. So whatever the condition of these inputs, I3, I2 and I1, this will become the don't care for this. Correct? So now you will have 0, 1 at the output. Now if this is your, now I1 is 1, and which has the lowest priority than this I0. So what will happen? Okay. I3, see here, I3 has the lowest priority now. It means we don't care about I3, I2 and I1. If I1 is high, which is having the highest priority, the output will be according to I0. Correct? Now the next condition comes when your no, what is
सर I0 1 है तो Y1 और Y0 दोनों 0 होना चाहिए ना? सर I0 हाई है ना, तो दोनों 0 0 होंगे.
okay. Okay, let me check with my somewhere I have written it. Okay. Yes, someone suggested me was right. Actually, when the inputs are all inputs are 0 0, we don't care about the outputs. It should not be 0 0. Because we want any of the inputs should be 1. So whenever all these inputs are 0 0 0, we don't care about the this outputs. We don't need actually this encoder circuit. So now this will be when one I0 is high, so the output will be 0 and 0. Correct? And now in this way, when I1 is high, we don't care about this. It should be 0. Correct? It should be 0, and we don't care about this too, because it has the priority less than this I0. So now the output will be 0 1. Now this will be the case, third case, where we don't care about the I3 and I2 will be high, and this will be 0, both I1 and I0. So the output will be 1 0, and this will be 1 and 0 0 0. So the output will be 1 and 1. Correct? So in this way, you can write the K-map equation for Y1. Okay, here I3, I2, I1 and I0. So you are writing K-map for Y1. So if I3 is 0 0 and I1 is also 0 0, so fill this entity. I will be solving only for Y1, Y2 will be the homework for you, Y0. So Y1, when all are 0, this will be don't care. When only I0 is 1, I0 is 1, I0 here, and it is 1 for this cell and this cell. You will be looking for only this Y1 and this two outputs. So let me see this 1 0 0. I2, I1 and I0. I2, I1 and I0. This is 1 0 0. So here you have 1 0 0. So this will be 1. And here also you have 1 0 0. So this will be 1. And for this 1 0 0 0. So 1 0 and 0 0. Correct. So all this will be 0 0 0 0. And how you make groups with the possible maximum you can cover. Here we can cover only four columns. So this will be your output of Y0. Expression for Y1 actually. Y1 is what? I1, I0, I1 bar, I0 bar. These two inputs are constant for whole this column. All other are variable. Similarly,
सर लास्ट रो भी 1 आएगी पूरी, क्योंकि I1 I0 वहाँ पे 1 0 है सर. लास्ट रो,
this one,
लास्ट 1 0 वाली.
yeah, here you want.
नो सर, सॉरी सर, कॉलम सर, लास्ट वन सर. 0 1 3 2 सर, 2 से जो होता है ना ये ऊपर.
No, actually we will fill for only this.
Okay sir.
Because we are looking at Y1. So Y1 is high when input is 1 0 0 0. So 1 0 0 0 is 1 0 0 0. So this will be the entity for this column on this input combination. So this way you calculate the priority encoder. And what will you do? You will have how you design. You will have your 4 inputs. It are I0, I1, I2, and I3. And when you want to design this Y1, so this will be the NAND gate of I1 and I0, NAND operation. Is it not NAND? This is your NAND operation. It is not. Okay, so you need 2 NOT gate and then 1 AND gate. So this is basically your NOR gate. When you have 2 NOT gate and AND gate, it becomes what it becomes? NOR gate. नो होल कॉम्प्लीमेंट नहीं आएगा. Okay, actually you can use two NOT gate and OR gate, whatever the combination comes, it will be your y1. Okay, so here you will have gates for this also and for this also. Correct? Should I rough this? Okay, now, so we will move to other encoder type, that is BCD to octal. Okay, or we can say binary to octal, actually binary to octal. Okay, let me make a simple question here. First we will encode decimal number decimal to binary. So you have in decimal number system, how many inputs you have? You can have 10, 0 to 10. So I0, 0 to 9 actually, and the total will be 10. 6, 7, 8, 9, 10. And at the output, how many outputs you require? 4. So this is decimal 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And the binary equivalent will require 4 bits. So 0 will be represented as 0, 0, 0, 0. 1 will be represented as 0, 0, 0, 1. Okay, so now what is this? You have this A, and you want to design, you want this output of this encoder. So what is the combination of the logic gates you can use to represent this? So when I say this is high, so it should be 0, 0, 0. What we were discussing, if let make it clear here, we don't use the priority. We okay, so any of this input will be only high, not 2 or 3. Only one input will be high at a time. So this is the assumption for this question. And now if this I want that if this is high, so what will be the output at this encoder? So the output will be 0, 0, 0. Correct? And if this one input of I1 will be high, so output will be 0, 0, 0, 1. Right? Similarly, so for this ABCD, now you want what the logic circuitry inside this encoder. Correct. So see, this is A is high for the min term. These are min terms. Let's suppose you have here what you have 0 to 9. So this A is high for 8 and 9. Correct. So if I can combine this with the OR gate here like this, here I8 is here and I9 is here, so it will produce this A. Similarly, if B I want to see, so this and this 4, 5, 6, 7, so this all will be the input of OR gate, and this will be attached to this B here. This is the output. So you can, let me rough this. So you can make OR gate here. So this is your A, and A is connected to 8 and 9. So 8 and 9. B, you will be a OR gate here, and B will be connected to 4. This 4, 5, 6, and 7. Similarly, D, C and D. So C will be 2, 3, 6, 7. So here you have 2, 3, 6, and 7. For D, alternates all the odd combination 1, 3, 5, 7, and 9. So this wire will be connected to D. So here the inputs are 1, 3, 5, and 9. So if any of the input will be high, so this circuitry will reflect at the output. Let's suppose 6 is high. So 6 is connected in B and C. So this B and C will be high. And because all these are zeros, so this will be 0, 0. So by looking at the output combination at the output, you can identify which input was there. So this is the conversion, decimal to binary. This is the decimal to binary encoder actually. In the encoder circuitry, you see this type of combination. Correct. So next, I will give 2 or 3 questions to you as an home assignment. These are basic or very simple questions. You can easily solve this. First is the conversion of hexadecimal to binary. Here you have seen the decimal to binary. Now the question is hexadecimal to binary. So you will require 16 inputs and the 4 outputs. Correct? Okay. So now we'll move to the decoder circuitry. Actually, it was very simple. So there is no rocket science in this encoder circuit. Okay. So as I mentioned earlier that decoder will have less number of inputs than encoder. So here we have two inputs, that is I0 and I1. So it is 2 cross 4 decoder. And this is your Y0, Y1, Y2, and Y3 are the outputs. Okay. So now what will be the circuitry inside this encoder for Y0, Y1, Y2, and Y3 we'll see. So there can be 4 combination for I0 and I1. This is your LSB. So accordingly, the output will be high. So which output should be high? We'll see. If 0, 0, 0, 0 at the input, so Y0 will be high, rest of all the outputs will be 0. If 0, 1 is at the input of this decoder, so Y0 will be 0, Y1 will be high, and it is very easy to fill. I will write it. Okay. So now you need to find out the Boolean function for this Y0, Y1, Y2, and Y3. So you can see it is very easy to find out. Y0 will be what? Y0 will be I bar, I1 bar, I0 bar. Correct? Similarly, Y1, I1 bar, I0, and this is I1, I0 bar. This will be I1, I0, Y3. So I will write it. Zero, 1. Okay, so if someone asks to design this, how will you have? This is your I1, and you need one NOT gate, I0. These are the input variables. Now you have one AND gate, and Y0 will be this I0 complement and I1 complement. So this is your Y0. Y1 will be I1 complement, I0 complement. This will be I1 and I0 complement, and your Y3 will be I1 and I2. So this is the encoder. So inside encoder, there is a combination of NOT gate and AND gate always. If you can able to identify, if you have 2 inputs at the decoder, all the minterms are generated at the output. Correct? So this is generating, let me write it simply, xy, so it is generating x bar, y bar. This is x bar y, this is x bar y, and x and y. Correct. So I mentioned at the initial time of this lecture that we can implement any Boolean function with the help of this decoder circuit. So if the question is that you need to implement full adder with the help of decoder, so will you do it? Is it easy? So at this the output of the full adder, what is the output of full adder? You have sum and carry. The sum is the minterm of 1, 2, and 4, 6, and 7. Do you remember this? No. Okay, so full adder will have how many inputs? 3 inputs. So let me solve for 2 inputs half adder. Okay, it will be simple. So you have 0 1 1 0 1 1. This is the input at the half adder, and the sum will be what? Sum will be 0 1 1 0 and carry 1 here. So this is the your sum, which is what? Which is the XOR operation between these two. So can I write XOR in this way? So similarly, this is written for the full adder. So if I am asking that implement half adder using 2x4 decoder, 2x4 decoder, so you have two outputs. One is sum, which is the min terms, which is 1 and 2, and the carry is min term, only third min term. Carry is only third min term. So how will you implement this? You need one decoder, which is 2x4 decoder. You have input I0 and I1. This is LSB bit. And output will be 4 output, Y0, Y1, Y2, and Y3. So now you know that each of this output is generating one min term. This is your min term M0, M1, M2, and M3. Correct? Now what you need? You need OR gate. One OR gate for the summation and one OR gate for carry. Here summation 1 and 2, the min term 1 and 2. So this will go into the input of this first OR gate. And this is your carry. Carry is only third min term. The input will be the third min term. So this is the implementation. Here we did the implementation of half adder using 2x4 decoder. Okay, now the question is to implement a full adder using 2x4 decoder. Is it possible? Implementing a full adder using 2x4 decoder. Is it possible? Full adder, for full adder, how many inputs you need? 3 inputs. So we need only one 2x4 decoder will not be sufficient. Okay. So there are another ICs that comes into the picture, that encoder comes with 3 into 8 decoder. So it will have 3 inputs and 8 outputs. So here you have 3 input variables, and according to that you will generate each min terms at the output. Y0 will be having 0 0 0, Y1 will be having 0 0 1, and so on. And with the help of this 3x8 decoder, you can implement one full adder. Correct? Is it easy? Will you do it? Okay. So here we will stop this lecture and we'll see further implementation. I will give one example here. If someone asks you to implement this Boolean function, here you have 4 variables. Implement this Boolean function using the decoder. So you can easily do it using the 4x16 decoder. Correct? So always in the GATE examination and IAS examination, there will be multiple choice of questions will be there based on this decoder. Always you will find 1 or 2 marks question in this competitive exam. Also in your this company interview, whatever the written test will they take. Campus placement. So be focused on this decoder. Decoder is very important topic for actually this whole subject. This digital circuit system, what is it? DCS. Some people call it digital design, digital electronics, and signal system. These 2 subjects are very important in this semester for you. And they are both easy also. But people make mistake in that because they are easy. correct? You think that it will be very easy to solve, and the wrong answer will be ticked in the question paper. That's why you have your poor performance in your quizzes also. If you will concentrate on the question, you will be able to solve it very perfectly. So here we end this lecture. So we will meet on next what? Wednesday. Welcome, welcome.